Hey everybody, welcome back. We're going to be um, looking at correlation in SPSS today. This is a fairly straightforward. Again, yeah, the longest part of the video is just setting up the data. So then just knowing what to click and being able to go ahead and run that correlation. So I'm going to go into SPSS window like we've done before. So you should see that now. The variable view in correlation, we really just need to name our two variables. So this example, excuse me, from the example we did by hand was the number of books that a child reads, and then the number of hours of TV they watch daily. So those are the two variables. We'll just call them that. Books for our first variable. It's numeric, no decimal values needed. It's a scale variable. And then our second one is we'll just call TV. That's numeric as well, no decimal values, and it is also a scale variable. So we're ready to go. We click to data view, and we have our two variables here. Under books, we're just going to put in our numbers. 0 books read for the first child, 7 for the second, 2 for the third, 1 for the fourth, 5 for the fifth, 4 for the sixth, 3 for the seventh, 3 for the eighth, 0 for the ninth, and 1 for the 10th child. And for hours of TV viewing, for the first child, we reported 3 hours daily, second child 1, third child 2, fourth child 2, fifth child 0, sixth child 1, seventh child 3, eighth child 2, ninth child 7, and 10th child 4. So that's it. That's all of our data. And just all I'm doing is clearing from an old data set. Since I'm shooting some of these videos in the same day, we had the old data set for one of our independent, dependent t-test or ANOVA videos that I shot. And I just want to make sure that it's not going to give us any missing data. So I just cleared a couple of old columns. Now we have our two variables in books. We got our data, we've got our TV data. We want to get the correlation. So again, we go up to Analyze, click that. We're going to come down to Correlate, and that's the first option you can see here is bivariate. That just means two by, right? And then variate, two variables, so two variable correlation here. We bring up the window for bivariate correlation. When we click on bivariate, we have our variables list over here, and we have the variables that we need to put in the analysis. We're going to include both variables because we want the correlation between these two variables. So we're going to click over with books. We're going to come back and grab TV, and we're going to click it over into the variables list. Now they're both here. You can see that down here, the correlation coefficient that it's going to calculate for us is defaulted to Pearson's product moment correlation. That's what we calculated by hand. The Kendall's tau, or TAW, and the Spearman correlation are different types of correlation used with different types of data. And we're not going to need those. It's not appropriate for the variables, the types of variables that we have here. And so we'll leave those alone. It's a two-tailed test we're going to run. It's defaulted to two-tailed test, and flag significant correlations means that if there's a significant correlation between books and TV, that it's going to tell us that with a little asterisk or maybe some asterisks. But the point is it's going to flag those with the asterisks. So it's defaulted to do that. We just leave that alone. The only other option up here, if we click on options, we can get the means and standard deviations for our group. I think that's always a good thing. You probably would normally want cross-product deviations and covariances as well, but that's sort of not really the purpose, again, of this introductory course, so we're not going to check that. Click continue once we have our means and standard deviations. We're going to click OK, and it's going to bring up an output window. So let me get that for you. And in the output window, the first box is our descriptive, or the first table is our descriptive statistics. Books, the average number of books read by the 10 children in our sample was 2.6 books with a standard deviation of 2.27. The average number of hours spent watching TV per day for the children, the 10 children in our sample, was 2.5 hours with a standard deviation of 1.96, 1.958, rounded to 1.96 two decimal places. The correlation is actually listed in the second table here, and some of this information is redundant. So the correlation, what they call matrix in SPSS, has ones on the diagonal, meaning if we drew a diagonal line down, right, then these are ones. The reason is because you can see that the first one, like this one, is books with books, right? And so these should be correlated perfectly because guess what? They're the same variable. And then if you do TV with TV, it's the same thing. They should be correlated perfectly because they're the same variable. The one that we want, whether we look at the bottom half or the top half, I was always taught to look up here in the top part. That's the same correlation, so this is redundant information. We just need to look at one of these, and we see that our Pearson's correlation is negative 0.725 or negative 0.73. And when we calculated it, we got a negative 0.77. I think that's, again, because of rounding. We're a little bit off, but we're essentially, that should be roughly comparable there. And so I think, again, it's due to rounding. I was going to check that real quick and just let you know. Yeah, I get the same correlation when I calculate it, at least by hand, or on my calculator there. I think the issue is we're rounding to two decimal places at each step of our hand calculation, and so sometimes that can be off by a little bit. You know, without rerunning the hand calculation, we could have made a computation mistake, I suppose, but it could be that it's due to rounding. The point is that SPSS is going to give us a roughly comparable, again, just probably due to rounding, but a comparable correlation to what we got by hand. So that's even, it was negative, right? The more books that a child is reading in this sample, the less the hours of TV viewing, or vice versa. The more TV viewing, the less books read. So there's a negative relationship between those two variables, and it is significant. So it has flagged it with the little asterisks here. And if you go down here with the asterisks, what it says is correlation is significant at the 0.05 level, two-tailed, right? But the actual p-value that we would want to report is right here, the significance level. And because this is less than 0.05, it is significant. So we reject the null, and we say that these two variables are significantly related. Now, one of the cool things in SPSS is that it can actually show us the data. And so if we go back to, well, I guess we don't have to go back, excuse me. We could go up to analyze, we come back to the correlate, and we go into bivariate. One of the things that we could have done here is, actually, let me make sure it's not in here. Yeah, I'm sorry, not in this way, but we can get a graph of the data. And so actually, it's under a graph function. You come up here to, in the output window, you can do this from the data window. You just want to find the graph. It lists the same headers at the top in either window. So I'm just in the output still, but you can click graphs and you can go to chart builder, right? And so this just brings up a window that says, before you use this dialog, measurement levels should be set properly for each variable in your chart. We already did that, so we can just click OK, right? And it brings up a window with the chart builder. And what we're going to want is we're just going to want a scatter plot of the data. So we go down to scatter dot, and we just click the first one, which is the basic scatter plot. And once it's highlighted, you can just actually drag it up into the window, the chart preview window. And you just let go, and it drops the chart in that you want to use, the type of chart. And then we just need to tell SPSS which is going to be our Y variable and which is going to be our X. Now in correlation, remember, it doesn't matter. But because we use the same example for regression, I want to show you that we used books to predict TV viewing, we're going to put books as our X variable, and all you do is you go up to your variables, you click books, and you hold it down, and then you drag books to the X-axis, right? And then you click TV, and you drag it to the Y-axis, and you just drop it once it highlights this little box. And so our variables are in everything. It doesn't look exactly like it should now, but when we click OK, it's going to build that chart that we told it to in SPSS. And so right here, the graph is the scatter plot of our data. So we can see the linear relationship between TV viewing and books. And we can see that because the line that would best fit this data slopes down and to the right, then we know that this is a negative relationship, right? The higher values of TV correspond to the lower values of books, and the lower values of books down here correspond to, the lower values of TV correspond to higher values of books. So we can see it's a negative relationship. And so I just like that because visually I like to look and see, well, what does the data look like? And SPSS will let you do that. So that's a kind of an added bonus. We did that maybe by hand when I was showing you. You can just plot this data out by hand. But with large data sets, maybe more than 10 scores, say, it's a lot easier to have SPSS plot those points out than to do it all by hand. So that's it for correlation. We're going to use the same data set for regression, but I'm going to include it in a different video so that this one doesn't get too long. Thanks.